It was a mystery many were trying to solve last year. What this unidentified object was found in our solar system.
Oumuamua.
Oumuamua.
Oumuamua, this object is simply a piece of another solar system that was expelled, and it has been traveling through interstellar space for hundreds of millions of years, billions of years, we don't know.
A strange object is threatening our solar system, sparking worldwide curiosity. Shining brighter than usual space debris, it sped up unexpectedly near the sun, defying normal gravity. Scientists are shocked by Oumuamua's strange behavior. It's heading towards Earth, and this time, it could be an unanticipated disaster. Could this be a sign of alien technology, or something even more dangerous? Let's explore why we must prepare for the return of an alien visitor who is more powerful than our wildest imaginations. The strange visitor who named Oumuamua. The big question was whether Oumuamua was a comet or an asteroid. These two types of celestial bodies, both orbiting the sun, differ significantly in their composition and behavior. Comets, often called dirty snowballs, are made up of ice mixed with dust and rock. When comets come close to the sun, the heat causes their ice to vaporize, releasing gas and dust into space, forming a bright, visible tail that stretches for millions of miles. Typically, comets travel along highly elliptical orbits that bring them in close to the sun from far reaches of the solar system. Asteroids, on the other hand, consist mainly of rock and metal. They are relics from the early days of the solar system, usually found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun because they contain no ice to vaporize. Their orbits are more circular than those of comets. Despite appearing to originate from another part of the universe, Oumuamua didn't show the usual behaviors associated with comets. It lacked a tail and didn't emit gas as it passed by, which was quite puzzling. Although it behaved in some ways like a comet, its appearance and other characteristics were more akin to those of an asteroid. This unusual combination of traits made Oumuamua a subject of intense study and curiosity, as it didn't fit neatly into existing categories of known space objects. One might wonder how scientists were even able to detect Oumuamua, given the immense scale of space in the brief window of human astronomical technology. Considering that stars exist for millions or even billions of years, and the development of solar systems takes hundreds of millions of years, the odds seem astonishing. The fastest space objects still require tens of thousands of years to travel from one star system to another. Yet human observation of the cosmos using telescopes spans only about 400 years, just a blink in cosmic time. In recent decades, advances in technology have enabled us to spot and monitor swift, faint objects that would have been invisible to us before. This leaves us to ponder whether such objects are common in the cosmos, or whether our detection of Oumuamua was a stroke of extraordinary luck, or perhaps it was simply meant to be observed. Exploring where such objects might originate raises further questions. It's improbable that Oumuamua was ejected from a stable, mature solar system, as these systems typically don't expel substantial amounts of material into space. While the occasional random rock might be hurled outward, its trip across vast distances is rare. On the other hand, younger solar systems exhibit a lot more chaotic activity, such as collisions and migrations, creating ideal conditions for ejecting small rocks into space. The solar system from which Oumuamua was expelled likely contained a planet with a mass similar to Jupiter, whose significant gravitational pull could fling other objects outward. However, not every solar system forms Jupiter-sized planets. Many instead develop massive planets that orbit very close to their stars, becoming hot versions of Jupiter that are less conducive to ejecting debris into space. Additionally, planets similar to Neptune might influence such dynamics as well. Although less massive than Jupiter, Neptune-like planets often reside in the outer parts of solar systems, akin to our own Kuiper Belt, a region teeming with cometary material. In the formative years of a solar system, interactions between such planets and surrounding debris are frequent. However, detecting Neptune-like planets in other systems remains challenging. Our current methods are more adept at spotting larger bodies that are closer to their stars, making it harder to identify similar distant features in other systems. Panspermia is a theory that proposes that life is widespread throughout the universe, and can be transferred between planets by asteroids, comets, or even spacecraft. According to panspermia, life likely started in one specific location and then spread to other celestial bodies across the galaxy. Proponents of this theory speculate that interstellar objects like Oumuamua could carry microscopic life forms, serving as catalysts to seed new planets or moons. While intriguing, there is currently no evidence to support the notion that this particular comet has carried life from one star system to another. Over years of detailed research, scientists have gradually reached the consensus that Oumuamua is most likely a comet. The peculiar way it moves could be explained by frozen hydrogen on its surface, which reacts with sunlight. As Oumuamua approached our sun, it sped up due to the release of this hydrogen, altering its trajectory. Additionally, its reddish color supports this idea, suggesting long exposure to cosmic rays, which could help it accumulate more hydrogen. While certainty remains elusive, astronomers have devised a plan to learn more about this intriguing visitor. They've proposed a mission, named Project Lyra, to send a spacecraft to intercept Oumuamua. Although it's now far from us, it's not too late to reach it. The mission plans to utilize the gravitational forces of Earth and Jupiter in a slingshot maneuver to accelerate a probe fast enough to catch up to the comet. If successful, Project Lyra would launch the fastest spacecraft ever into deep space. The craft would use Earth's gravity for an initial boost, swing by near Jupiter, and then make a final pass by Earth to gain the necessary speed to reach Oumuamua. Diving deeper into the cosmos, let's examine two unique space visitors and their implications. Examining the stars for Planet 9, Project Lyra also aims to explore another interstellar visitor called Borisov, discovered by an amateur astronomer and named after him. Like Oumuamua, Borisov is unique and relatively unblemished. Since its detection in August 2019, Borisov has offered astronomers a longer window to study its characteristics as it travels through our solar system. Observations show that Borisov emits a remarkably clean and polarized light from its dust cloud, unlike other cometary bodies. Analysis reveals that it discharges over 400 pounds of dust per second and contains varying levels of carbon monoxide, suggestive of its formation near its home star before being pushed outward, potentially by larger planetary bodies. The pristine condition of its dust cloud indicates that Borisov has not interacted with other stars, hinting that we might be on the brink of discovering a massive, icy planet far beyond Neptune. Apologies to Pluto, but it's still not about you. In related studies, recent mapping efforts using data from a Hawaiian telescope have narrowed down about 78% of potential locations for a hypothetical planet often referred to as Planet 9 or Planet X. This elusive object has sparked considerable debate since its existence was first posited, largely due to the lack of concrete evidence confirming its reality. If it exists, Planet 9 would be the fifth largest planet in our solar system, with a mass about 10 times that of Earth and a gaseous composition akin to Uranus. Proposed studies from 2016 suggest that Planet 9 orbits the Sun at a distance 29 times further than Neptune, taking between 10,000 and 20,000 years to complete one orbit. If confirmed, this mysterious giant would dominate a vast region larger than any other known planet in our vicinity, adding a new frontier to our understanding of the solar system. These theories are fascinating, yet they stand without solid proof or observation to support them. It's crucial to understand that the researchers suggesting the existence of Planet 9 have relied on intricate mathematical models and computer simulations to explore the possible characteristics of this planet because this is their area of expertise. They propose that the presence of this hypothetical planet could explain several mysterious phenomena observed beyond Neptune. Specifically, they focus on the Kuiper Belt, a vast donut-shaped region teeming with icy debris left from the solar system's formation, which includes comets and dwarf planets like Pluto. Intriguingly, the six most distant known objects in the Kuiper Belt all follow elliptical orbits aligned in a similar direction and tilted about 30 degrees downward relative to the orbital plane of the other planets. Despite their differing speeds around the solar system, these objects maintain this peculiar alignment. The probability of such an alignment happening by chance is incredibly slim, about 0.07%. Thus, Planet 9 is theorized as a massive celestial body whose gravitational forces might be orchestrating this unusual orbital configuration. The initial theory, however, faced scrutiny over potential observational biases and calculation mistakes. But in 2017, renewed interest emerged with a study by Spanish astronomers who adopted a fresh method by focusing on extreme trans-Neptunian objects, which orbit the Sun along highly elongated paths and are positioned an average distance exceeding 13 billion miles from it. This study examined the distances of these objects' nodes, points where their orbits cross the solar system's plane, from the Sun, seeking clues about Planet 9's whereabouts. At these nodes, these bodies are more prone to gravitational interactions with other solar bodies, which could alter their orbits or even cause collisions. The stability of these trans-Neptunian objects' orbits could indicate a calm solar neighborhood, but any disruptions might hint at the gravitational pull of a large unseen planet. The findings pointed to an unseen force altering these objects' paths, suggesting the possible existence of a distant planet estimated to be about 300 to 400 times farther from the Sun than Earth. To date, these observations provide the strongest evidence supporting the existence of Planet 9. If there's skepticism about this theory, consider that such abnormal celestial movements have historically led to new planetary discoveries. For example, Neptune was discovered due to irregularities in Uranus's orbit that didn't match predictions based on Newtonian gravity. The anomalies suggested the influence of an undiscovered planet leading to Neptune's eventual discovery. Fast forward to 2021, and there's renewed excitement about Planet 9. Recent studies suggest it might orbit the Sun in a colossal loop every 7,000 years. A groundbreaking revelation because it implies the planet could be closer than previously thought, potentially within the observational reach of our telescopes. Moreover, the latest research posits a 99% probability that these unusual orbits are influenced by this hidden planet rather than being mere cosmic coincidences. This ongoing investigation continues to draw attention and fuel debates in the scientific community about the elusive Planet 9. Now, the probability of the entire Planet 9 scenario being just a coincidence has dropped significantly, from a mere 1 in 10,000 chance in 2016 to a 1 in 250 chance today. These more encouraging statistics have propelled us forward, fueling our optimism and driving the development of more advanced equipment dedicated to the ongoing quest to find Planet 9. As previously mentioned, researchers in Hawaii have utilized the Panoramic Survey Telescope and Rapid Response System to create a sort of treasure map, successfully ruling out 78% of the possible locations for Planet 9. This is quite an achievement, especially when you consider the immense challenge of locating a planet-sized object hidden within the vast cosmic expanse. Despite these efforts, the existence of Planet 9 remains elusive, like a phantom lurking in the dark, distant fringes of our solar system. Yet many enthusiasts are confident that it's only a matter of time until we mark the discovery of what could be Earth's new cosmic neighbor. Their hopes are now pinned on the Vera Rubin Observatory, currently being constructed in Chile and set to start its scientific missions by late 2025. Over a span of 10 years, this observatory will conduct a comprehensive scan of the entire southern hemisphere's sky every few nights, utilizing a massive 27-ton telescope equipped with the world's largest digital camera. The goal is to catalog every object in the solar system out to and beyond Neptune, monitoring the movements of millions of celestial bodies, including space debris, asteroids, comets, and stars. If Planet 9 does exist, this cutting-edge telescope might just be the tool that finally spots it. Next, we explore the debate over a potential hidden planet at the edge of our solar system, Andromeda's future crash into the Milky Way. However, the concept of Planet 9 is not without its skeptics within the scientific community, primarily because it isn't the sole possible explanation for the unusual occurrences observed beyond Neptune. One alternative theory proposes that a cluster of distant celestial bodies, including dwarf planets, comets, and moons, could be collectively affecting the orbits of extreme trans-Neptunian objects. Others speculate that the gravitational effects observed could be the work of a black hole, one of the densest entities in the cosmos. This black hole could exert significant influence on surrounding objects in a manner similar to the hypothesized effects of planet Earth 9. Another intriguing idea is that our current understanding of gravitational laws might be incomplete. This concept, known as modified Newtonian dynamics, suggests that the peculiar behavior of these distant icy objects may be influenced not by another planet, but by the vast gravitational field of the Milky Way itself. However, even proponents of this theory agree that it's premature to draw definitive conclusions, acknowledging that much more research is necessary to explore these possibilities fully. Amidst this ongoing search for Planet 9, some astronomers have even proposed the potential existence of a Planet 10. This hypothetical planet is thought to have a mass and size similar to Mars or Earth, and is posited to be located on the edges of the Kuiper Belt. However, if this proposed Planet 10 is as small as some believe, it might not possess sufficient gravitational force to clear its orbit of debris, similar to the issue that led to Pluto being reclassified as a dwarf planet in 2006. Thus, while it's an exciting prospect, it's prudent not to get overly enthusiastic. This potential Planet 10 could also end up being categorized as another dwarf planet. Meanwhile, Earth's magnetic field holds its own captivating tale. It has been gradually weakening for the last 3,000 years. If this trend continues, we could face significant challenges within the next 1,000 years. Imagine this: magnetic north and south poles swapping places. This scenario isn't just fascinating, it's a bit daunting too. During such a flip, Earth's protective magnetic shield could diminish, increasing our vulnerability to cosmic rays. These high-energy particles from space have the potential to disrupt electronics and satellites and create harmful radiation exposure on Earth. The most recent polarity reversal happened roughly 773,000 years ago. Fortunately, we have skilled researchers diligently studying Earth's magnetic field history. They analyze cores from seafloor sediments and fossil magnetization to better understand past reversals and predict when the next one might occur. A team of researchers is currently delving deep into the secrets of the South Atlantic anomaly, a significant weak spot in Earth's magnetic field that is about 3 times less intense than the magnetic field at the poles. By analyzing data from various satellites, these scientists are striving to understand the causes of the South Atlantic anomaly and how it might evolve over time. Their research could reveal important insights into the potential impacts of a diminished magnetic field on both our satellites and our planet itself. While we won't be around to see these changes, it's intriguing to imagine a world where the magnetic poles are flipped. In astronomical terms, National Aeronautics and Space Administration has predicted a dramatic future event for our galaxy. In about 4 billion years, the Milky Way is expected to experience a significant transformation through a colossal collision with the Andromeda Galaxy. This isn't just a minor scrape, but a monumental crash that will see our solar system potentially relocated within the galaxy. Despite the scale of this galactic event, it's believed that our Earth and solar system will likely remain unscathed. This may seem hard to believe, but extensive measurements by National Aeronautics and Space Administration's Hubble Space Telescope of Andromeda's trajectory suggest that although the galaxies will merge, the vast distances between stars mean that direct collisions are unlikely. Instead, stars will be redistributed into new orbits around the merged galactic core, and our solar system could find itself further from this new center. There's no need to mark your calendars or set your telescopes for this event, however, as it's set to occur long after our time. Saturn's iconic rings are gradually disappearing. This phenomenon, often described as ring rain, involves ice particles from the rings being pulled into Saturn by the planet's magnetic field. National Aeronautics and Space Administration studies have estimated that this process is depleting water content from the rings at a rate sufficient to fill an Olympic-sized swimming pool every half hour. At this rate, Saturn's rings are expected to vanish within 300 million years. It's fortunate that we have the opportunity to observe these rings today, as they are likely halfway through their existence. This transient nature of planetary rings suggests that we might have already missed witnessing massive ring systems around other planets like Jupiter, Uranus, and Neptune, which now only possess faint, thin rings. The origin of Saturn's rings has sparked much debate among scientists. Recent research supports the idea that Saturn did not form with its rings, but acquired them later, possibly less than 100 million years ago. Theories about how the rings formed include possible collisions between Saturn's moons or disruptions caused by the gravitational pull of a passing comet or asteroid. It's fascinating to speculate on how humanity might evolve in the future. While we won't see drastic changes in our lifetimes, pondering our future forms is intriguing. Will we integrate technology into our bodies, becoming cyborgs enhanced with mechanical implants? Or might we evolve into a hybrid species, blending biological and artificial elements? To foresee our evolutionary path, it's helpful to reflect on our past. 1 million years ago, Homo sapiens did not exist, and Neanderthals roamed the earth. Since then, humans have grown taller and more robust. Perhaps in the distant future, humans might adapt to become smaller to save energy, especially as our planet becomes increasingly populated. Let's consider how humans might adapt to life on an overcrowded Earth and beyond. The revolutionary genetic shifts when you live on Mars. Talking about densely populated planets, adapting to these new environments is a must, and it needs to happen quickly. We're constantly mingling with numerous people, and the ability to remember names is increasingly becoming a vital skill. Fortunately, technology might offer a solution with potential brain implants designed to boost our memory. In the future, technology could also become a more visible part of our appearance. Picture having an artificial eye equipped with a camera that can detect various light frequencies. While making predictions 1 million years into the future is purely speculative, we can use bioinformatics to forecast some near-future scenarios. Demographic studies indicate that urban regions will likely see increased genetic diversity, whereas rural areas may experience a decline in diversity. Turning our gaze to space, if humans manage to colonize Mars, our bodies might undergo changes due to the planet's lower gravity. We could develop longer arms and legs, or even grow a layer of insulating body hair, reminiscent of our Neanderthal ancestors. Looking further ahead, our moon is set to experience some drastic transformations too. Changes we'll also miss witnessing. In about 5 billion years, our corner of the universe will become quite dramatic. Currently, the sun is in its main sequence phase, steadily burning hydrogen. In its future red giant phase, the sun will expand massively until it engulfs both Earth and the moon. The moon, which is gradually drifting away from Earth, will experience a chaotic alteration in its orbit. It will swing closer to Earth during the new moon phase than during the full moon phase. But that's just the beginning. If nothing interferes, the moon's orbit will continue to extend until it takes nearly 50 days to complete one orbit around Earth. As the sun evolves, its expansive atmosphere will exert drag on the moon, leading to orbital decay. Eventually, the moon could disintegrate into a spectacular ring of debris encircling Earth. Imagine all its mountains, craters, and even the historical footprints and flags left by astronauts, all strewn across a belt of rubble. There's a possibility that the sun might lose enough mass to prevent total destruction of Earth and the moon, or, if we're extremely fortunate, the sun will shed 20% of its mass and will remain safe. However, these scenarios remain theoretical. We've never observed a red giant star in this specific phase. The universe might one day go completely dark as well. While scientists can't predict this with absolute certainty, they can make educated estimates. Our universe, currently 13.77 billion years old, is still actively forming new stars. Eventually, perhaps in about 1 trillion years, the last star will form. A small red dwarf, much smaller than our sun. These red dwarfs are the ultimate survivors, burning hydrogen slowly to maintain their fusion reactions for eons. Yet even they will not last indefinitely. Fast forward around 100 trillion years, and the last flicker of light will extinguish. So the universe will become a dark, empty place. But thankfully, we won't be around to see this gradual fade into nothingness. If a colossal asteroid like Apus were to strike Earth, it would lead to catastrophic destruction. Massive earthquakes would shake the planet, and tsunamis would inundate our landscapes. Apus, a billion-year-old celestial body that has been around since the dawn of our solar system, poses a theoretical but daunting risk of colliding with Earth in 2029. In 2004, a massive and menacing asteroid was discovered by the Kitt Peak National Observatory in Arizona. Since its discovery, it has been known as one of the most dangerous asteroids ever identified. Measuring approximately 1,100 feet in width, This asteroid is somewhat larger than both the Empire State Building and the Eiffel Tower. Due to its intimidating presence, it was aptly named Aus, after the Egyptian mythical creature believed to bring darkness and destruction to Earth. Fast forward to 2021, researchers seized a rare opportunity to closely study this massive rock, as it made a close approach to our planet, a moment we'll revisit shortly. Some experts have raised concerns about the small but real possibility of Aus striking Earth on Friday, April 13, 2029. This potential threat is attributed to the Yarkovsky effect, a phenomenon that causes the asteroid to drift slightly towards Earth due to the uneven emission of thermal photons from its spinning surface. This emission results in a subtle yet significant force that could alter the asteroid's path through space. These photons carry momentum which significantly influences the asteroid's motion. Much like the Moon, Aus has two distinct sides, one facing the Sun and absorbing more heat, and a darker, cooler side. However, the asteroid rotates, causing these sides to continuously swap, adjusting their exposure to the Sun and consequently their temperatures. This ongoing change poses a risk as it may nudge Aus slightly towards our planet, though the exact impact of the Yarkovsky effect on its trajectory remains uncertain. During its last close encounter with Earth in 2021, astronomers utilized radar technology to precisely track its path, confidently determining that Aus will miss Earth by about 20,000 miles in 2029 and is unlikely to pose a threat for at least another century. Historically, Earth is impacted by large celestial objects approximately every 8,000 years, with dimensions similar to Aus. The most recent smaller-scale impact occurred in 2013. Following that event, National Aeronautics and Space Administration launched the OSIRIS-REx spacecraft in 2016 to gather samples from Bennu, a less daunting asteroid. By 2020, OSIRIS-REx had successfully collected samples and commenced its trip back to Earth, eventually securing the samples in Utah. This mission marked the most significant asteroid sample retrieval to date. After depositing the Bennu samples, the spacecraft, renamed OSIRIS-APEX, redirected its mission to pursue Aus. Assuming all goes well, OSIRIS-APEX will rendezvous with Aus on April 2, 2029, as the asteroid makes another close pass by Earth. The spacecraft is expected to land on the asteroid and spend 18 months there, collecting data and taking thousands of photographs, which will be invaluable for monitoring and research. Eventually, as Aus approaches too close to the Sun, the responsibility of monitoring will rely entirely on OSIRIS-APEX. Residents of Europe, West Asia, or Africa will find themselves particularly fortunate as they will have the unique opportunity to observe Aus with the naked eye in 2029, with a subsequent chance to view it again in 2036 using telescopes. However, the mission faces challenges, particularly due to Aus's dense crust, which complicates data collection more so than it did with Bennu. To overcome this, OSIRIS-APEX is equipped with a special thruster designed to clear surface dust upon landing, allowing for detailed analysis of the asteroid's composition. Over 1.5 years, the spacecraft will map the asteroid, monitoring changes in its form. This extensive research will enhance our understanding of how such celestial bodies move, enabling better preparation and protective measures against potential future threats. Returning to the cosmos, we examine how stars and galaxies form, revealing the universe's past and potential future. Inside the Tarantula Nebula, where stars are born. Stephen Quintet is a remarkable cluster of 5 galaxies located in the distant constellation of Pegasus, about 290 million light-years away from Earth. This group acts like a cosmic family, with each galaxy closely related and interacting dynamically with the others. They exert gravitational pulls on one another, continuously exchanging streams of gas and dust. These interactions often lead to dramatic events like galactic collisions and mergers, sparking new star formations and brilliant supernovae. With the help of the James Webb Space Telescope, we've been able to observe incredible phenomena such as shock waves and tidal tails within these galaxies, providing us with a spectacular view of their complex dynamics. Turning our gaze closer to home, we find Jupiter, the behemoth of our solar system. An image captured by National Aeronautics and Space Administration on August 22nd showcases Jupiter's grandeur. complete with its numerous moons and iconic swirling clouds. But beyond these, Jupiter boasts a ring system, much like Saturn's, though far less conspicuous, composed of fine dust particles that circle the planet. These rings, while subtler and smaller than those of Saturn, add to Jupiter's unique charm. Jupiter is also famous for its vivid auroras, which are even more intense and colorful than those on Earth, caused by the interaction of the solar wind with Jupiter's powerful magnetic field. These spectacular light shows are usually seen near the planet's poles and are so bright that they can be viewed from space. The recent James Webb Space Telescope image not only captured these dazzling auroras, but also detailed views of Jupiter's rings and two of its moons, Amalthea and Adrastea, highlighting their clarity and brilliance against the backdrop of space. Further afield lies the Cartwheel Galaxy, revealed in a National Aeronautics and Space Administration image released on August 2nd. This galaxy is aptly named for its cartwheel-like appearance, featuring a central hub surrounded by an expansive ring of stars, gas, and dust. The structure of the Cartwheel Galaxy is maintained by the gravitational pull from its core region, which houses a supermassive black hole. Unlike typical spiral galaxies, the Cartwheel Galaxy's distinctive shape was formed by a high-impact collision with a smaller galaxy, sending shock waves that shaped its current form. This galaxy, with its dynamic and somewhat violent history, promises a thrilling exploration target for future astronomers.
The darkest secrets of the first interstellar asteroid. In October 2017, astronomers found something amazing and completely new. It was the first time we spotted an object from another part of our galaxy passing through our solar system. This discovery hinted at an exciting idea. The vast universe might be filled with places not so different from our own Earth. The Pan-STARRS telescope, located in Hawaii, was the one to spot this unusual visitor. It saw a strange, dim shape in the sky on October 19, 2017, while it was looking out for asteroids that could come too close to Earth. The route this object was taking was like nothing ever seen before. It was moving in a way that told scientists this object hadn't come from our solar system. This object was named Oumuamua, which means a scout or a messenger from far away in Hawaiian. It looked like a long, narrow cigar, or perhaps a big rock stick, zooming through space standing up. This was exciting because it was the first time we saw an asteroid from another star system visiting ours. Oumuamua didn't look like the usual round rocks or ice balls we see flying around the sun. It was flat and long, which was really unusual and hard to explain. This made some people wonder if it might be something made by aliens. A famous scientist, Michio Kaku, made everyone pay attention when he said that Oumuamua could hit Earth in 2 weeks and might even be a signal from an alien civilization. This mysterious space rock brings up a lot of questions. What exactly is it? Where did it come from? Why did it come here? And why does Kaku think it's an important warning from outer space? There's an old saying that goes, "Visit the galaxy before the galaxy visits you." Well, in 2017, the universe decided to drop by our home. Scientists saw a weird, reddish, cigar-like object flying through our solar system really fast, about 24,850 miles per hour. They named it Oumuamua, which fits perfectly because it seemed like a scout or messenger from the stars. It was only possible to see it for a little while. The sudden appearance of Oumuamua made people think of stories and movies where humans meet strange things from space. It reminded some of a book by Arthur C. Clarke called Rendezvous with Rama, about astronauts finding an alien ship. Others thought of 2001, A Space Odyssey, where mysterious objects help humans advance. The discovery of Oumuamua caused a huge rush among scientists all over the world. They all wanted to use telescopes to look at this strange visitor. Even the SETI Institute, which tries to find alien life by listening for their signals, got excited and started to check if Oumuamua was sending any messages. Oumuamua is a very unusual space rock that looks a bit like the asteroids we know about, which sometimes make us worry they might crash into Earth. It's kind of the same color and has some similar features. But there's something really special about Oumuamua that makes it stand out. Its shape. It's incredibly long, like 800 yards, and it's only about 80 yards wide. That means it's about 10 times longer than it is wide, which is not something you see every day with space rocks. Long ago, people who study stars and planets, called astronomers, thought that chunks of ice getting kicked out from the areas where planets are born far away in space might travel all the way to our solar system. They figured these icy bits would start to melt and glow a bit when they got close to our sun, looking like comets with their tails shining and all. But this glowing tail thing? It never actually happened with Oumuamua. Astronomers have figured out why Oumuamua didn't light up like they expected. This rock is really faint and dark, so you can only see it if you have a super powerful telescope that can look at a huge part of the sky at once, like the Pan-STARRS telescope in Hawaii. Plus, Oumuamua does this interesting thing where it gets brighter and then dimmer every 7.3 hours. This tells us it's spinning around a short side of itself. The fact that it can spin so fast without breaking apart tells scientists that Oumuamua is made of some really tough stuff, not just the icy bits you find in comets. When scientists looked at Oumuamua with special tools that let them see what it's made of, they noticed it has a dark red color. This is similar to some of the moons way out in our solar system that look red because sunlight changes their surface chemicals. A scientist named Dr. Mich thinks this red color might come from organic stuff, like the building blocks of life, changed by space radiation, or maybe even from iron. But where did Oumuamua come from? That's a big mystery. Dr. Mich and others wonder if it might have been thrown out into space by a huge star explosion, or if it came together from bits and pieces of stuff smashing together out there in the universe. We're still not sure. When people first noticed Oumuamua, they thought it might have come from the direction of a very bright star called Vega in the constellation Lyra, which has lots of space dust and rocks around it. They thought maybe Oumuamua traveled from there to here, which would have taken about 600,000 years. That's a really long trip, and it's just one guess about where this strange space traveler might have started its journey. Having traced Oumuamua's unique journey, we now dive deeper into the secrets it carries across galaxies. The mystery of this interstellar traveler unfolds further. A billion-year trek through the galaxy. But as scientists took a closer look at where Oumuamua was headed, they started to think that maybe it didn't really come from Vega after all. They noticed that Oumuamua had moved a bit differently than they first thought. It seems like it might have swung by another star system before visiting us, kind of like a cosmic tourist checking out different spots in the galaxy. Its speed is a lot like the speed of the stars close to our sun, which made the scientists think that maybe Oumuamua has been on a long, long journey across the galaxy for maybe even billions of years. Imagine looking up at the night sky. You see stars twinkling alone or in groups, and it's pretty. But think about this. The trips that Oumuamua and other space rocks like it are on give us a whole new way to see the galaxy. The gold in someone's wedding ring came from stars smashing into each other a super long time ago. The stuff we breathe and the iron in our blood came from stars blowing up far away in space and time. We're starting to understand that bits of Mars have flown through space and landed on Earth because of asteroids bumping into Mars. Some really smart space scientists even think that life on Earth might have hitched a ride on one of those Mars rocks, back when Mars had water and was nicer to live on. To really get how we fit into the big picture of the universe, we have to think about these far-out ideas and look way, way back in time and out into space. Now, let's think about how far Oumuamua might have traveled. It's been moving through space for hundreds of thousands of years. That sounds like forever to us, but in space-time, it's just a quick trip. Our Milky Way galaxy is super old, about 10 billion years old. So, in all that time, Oumuamua could have passed by around 20,000 different star systems. That might sound like a lot, but it's only a tiny piece of the galaxy, which has about 200 billion stars. Still, every star system Oumuamua visited added a little bit to its story. It picked up dust and little bits from all over the galaxy. This makes some people think that maybe space isn't as big and empty as we used to think. Maybe everything in the universe is more connected than we realized. Even though we can't see Oumuamua anymore, it's still somewhere close to our solar system. Elon Musk along with many astronomers, is keeping an eye on its journey. They think Oumuamua will pass through an area called the Kuiper Belt around 2024. This belt is like a cosmic neighborhood of icy objects and rocks far beyond the planets. By the end of 2025, they expect Oumuamua to be at the very edge of this area. What's really exciting is that by 2038, it might even pass by the point in space where the Voyager spacecraft are, which are the farthest human-made objects from Earth. Scientists have also made some pretty wild guesses about the future. They think that by the year 2196, the outer boundary of our solar system, known as the Oort cloud, will stretch out super far, over 100,000 astronomical units away. But then, it'll come back closer, to about 1,000 AU from the Sun. So depending on how you look at where our solar system ends, Oumuamua might officially leave it at different times. At first, everyone thought Oumuamua was just a regular asteroid because it's big, about 2,600 feet long and 260 feet wide, but then it started acting weird. Instead of moving through space like most space rocks, it sped up and moved in ways that gravity alone couldn't explain. Dr. Meech and her team thought really hard about why this could be happening. They came up with 6 different ideas, but ended up saying no to a bunch of them. Some ideas were too crazy, like thinking Oumuamua might be lighter than the fluffiest material on Earth, aerogel. Other ideas didn't match up with what they were seeing in space. After a lot of thinking and looking at the data, they figured out that Oumuamua was acting like a comet that's getting a speed boost from the sun. When comets get close to the sun, their icy bits turn into gas in a flash, shooting out and pushing the comet to go faster or change direction. This is called outgassing. Dr. Meech said that the way Oumuamua moved was pretty much what you'd expect if it were outgassing like a comet, so it didn't seem weird to her. But there was one thing that puzzled them. Usually, when a comet outgasses, it throws off dust that we can see from Earth. The more gas it shoots out, the more dust you'd expect to see flying off too. This dust is like a comet's trail that we can spot with telescopes. But Oumuamua didn't seem to be losing any dust, or at least not enough that we could see. This was odd because even without tiny bits of stuff coming off, you'd think there would still be some bigger dust particles getting pushed out. The fact that Oumuamua didn't have a visible dust cloud, but still was moving like a comet, made it super interesting and kept scientists hooked on figuring out more about this mysterious space visitor. Oumuamua might just be passing through, but its quiet trip could unlock new truths about the stars. We're on the brink of possibly groundbreaking discoveries. The reflective traveler from light years away. So when scientists were trying to figure out what was going on with Oumuamua, they looked at it in a way that usually helps spot big dust particles floating around in space. But they didn't see any dust coming off Oumuamua, which was pretty weird. And when they tried to find any signs of gas, something you'd expect a lot of if Oumuamua were acting like a comet, they came up empty-handed there too. They were especially looking for a type of gas called CN gas because it's usually pretty easy to spot and often hangs out with water, which is tougher to see directly. If comets from our neck of the woods in space have water, they usually have CN gas too. But Oumuamua? It didn't show any signs of CN gas at all. This was a big deal because it hinted that Oumuamua might be made up of stuff that's not like the comets we're used to here. It might have come from a place where things are quite different, which wouldn't be too shocking since it's not from around here. Then there's another layer to this space mystery. Scientists used a fancy space camera called the Spitzer Space Telescope to take a really close look at Oumuamua in a type of light called infrared for more than 30 hours. Infrared is great for seeing how warm things are, but even after all that spying, they didn't see anything. Now you might think that seeing nothing isn't helpful, but sometimes it actually tells you a lot. From this big nothing, they figured out Oumuamua might actually be shinier and reflect more light than they thought it would if it were just a regular comet. When you shine a light on something and look at how much light bounces back, you can learn a lot about what it's made of, how big it is, and what shape it is. Dr. Meech and her team thought Oumuamua would be pretty dull, reflecting about 4% of the light, like most comets do. But nope, Oumuamua was bouncing back about 10% of the light that hit it. This was a head-scratcher, because it didn't match up with the idea of Oumuamua being just another comet floating through space. Dr. Meach pointed out that for Oumuamua to look like a comet in the infrared, but have a reflectivity of 10%, it would have to be quite different in terms of the stuff on its surface compared to other comets. This made Oumuamua even more of a mystery. It's like it's playing by a different set of rules, and figuring out those rules could tell us something really cool about where it came from and what it's made of. In addition, when scientists tried to find out if Oumuamua was letting out any carbon monoxide or carbon dioxide gases, they couldn't find any. This was a pretty big deal because the team led by Dr. Meach had thought maybe Oumuamua might be releasing these gases. They even thought it could be doing this a lot more than what they ended up observing, but their equipment, even as advanced as the Spitzer Space Telescope, just didn't pick up any signs of these gases. This lack of gas is intriguing because Oumuamua comes from another solar system entirely. It might mean that the kinds of things we're seeing with Oumuamua, like not having certain gases, are actually pretty normal for space rocks from other places in the universe. Then there's this scientist, Corinne Bohr-Jones, who works at the Max Planck Institute for Astronomy in Germany. Jones did something like detective work, tracing Oumuamua's path back through space to before it visited us. By using the information from a space mission called Gaia, which has been keeping track of where millions of stars are and how they move, Jones tried to match Oumuamua's backtracked path with the stars' paths. This was like rewinding a movie to see if Oumuamua and any of these stars were once in the same place at the same time, which could mean Oumuamua used to hang out around one of them. Jones found 4 stars that might have been places Oumuamua came from, but there was a catch. When Oumuamua would have left any of these stars, it would have been moving really, really fast. Much faster than we'd think a small space rock or a bit of a planet could get kicked out into space. We were expecting speeds a lot slower, but Oumuamua's actual speeds were way higher. This high speed makes it a bit tricky to say for sure that Oumuamua came from around these stars, especially since we usually think such fast speeds are more likely if a space rock gets booted out by 2 stars close together, not just one. But none of the 4 star systems Jones looked at were known to be pairs of stars. There's hope, though, that as we get more data from space missions like Gaia in the future, we might find a better match for where Oumuamua came from. This kind of space detective work takes time, and new information could help solve the mystery of Oumuamua's home. For now, Oumuamua holds the special title of being the first visitor from another star system that we've spotted cruising through our own. It's a reminder of how much there is to learn about our universe and the exciting possibilities that lie in the vast space between the stars. The puzzle of Oumuamua challenges scientists, potentially pointing to a reality we've yet to grasp. The debate over its purpose and origins grows. Space seeds on a galactic wind. The mystery of Oumuamua, a space object like no other we've seen before, has captured the imagination of scientists and space enthusiasts all over the globe. Its unusual appearance and behavior have sparked a fascinating conversation. Could it possibly be a sign of alien life? The speculation doesn't just come from the public's love for science fiction, but from some of the brightest minds in the field. A notable theory, proposed by an esteemed Harvard scientist alongside a Pentagon official known for investigating unexplained aerial phenomena, presents an intriguing possibility straight out of a sci-fi blockbuster. They suggest that a colossal spaceship from another civilization, reminiscent of a mothership in tales of interstellar voyages, could be lurking within the boundaries of our solar system. This hypothetical mothership might be dispatching minuscule probes, similar in concept to dandelion seeds blown by the wind, on a mission to explore the planets of our solar system. Imagine these tiny probes, each a marvel of alien technology, zipping around our solar system, gathering data on various planets and relaying their findings back to their mothership. This concept mirrors our own ventures into space, where we send out probes and rovers to distant planets like Mars, gathering data to quench our thirst for knowledge about the cosmos. Sean M. Kirkpatrick, a key figure in the Pentagon dedicated to unraveling the mysteries of UFOs and other unidentified objects, alongside Avi Loeb, a renowned astronomer at Harvard University, are the minds behind this captivating hypothesis. Together, they've laid out their thoughts in a paper that, while not an official document from the Pentagon, invites us to open our minds to the endless possibilities that the universe may hold. Avi Loeb, a scientist who spends a lot of time thinking about outer space, has been really curious about Oumuamua ever since it was discovered. He's even floated the idea that Oumuamua isn't just any old space rock. It might actually be a device sent by aliens to check us out. Adding to the intrigue, about half a year before anyone had even heard of Oumuamua, a smaller space rock came hurtling into Earth from another star system. This rock, known as IM-2, was pretty small, no bigger than 3 feet in diameter, but it got a lot of people, including Loeb, very excited. Loeb started wondering if this little rock was part of a larger scheme by aliens, where a massive spaceship out there somewhere was launching tons of tiny probes to get a closer look at planets like ours. These tiny space explorers, kind of like the seeds of a dandelion that float away in the breeze, might have been sent drifting across space by the push of the sun's gravity, or by their own little engines. The thought of it is pretty out there, kind of like the plot of a science fiction story, but it's got some of the smartest minds buzzing with ideas. They're all trying to piece together the puzzle of Oumuamua and similar mysterious objects that drift into our solar system from the vast reaches of space. They're using their imaginations to think up stories about where these objects might have come from and what their true nature might be. In their study of mysterious space objects, which the government calls unidentified anomalous phenomena instead of UFOs, Len Kirkpatrick and their team focused on what's known in science today. They wondered if tiny probes from space might be too small to catch any light for our telescopes to see. This would mean these little space explorers could travel all the way to Earth without anyone noticing. The team also thought about how these tiny probes could slow down when they reach Earth's atmosphere. They wouldn't want to go too fast and burn up, right? So, if these probes were built in a smart way, with a big surface area compared to their weight, they could float down gently. It makes sense that beings from another planet might want to learn about places like Venus, Earth, and Mars, since they're rocky and have atmospheres. Earth would be especially interesting because it has water. The idea was that the big spaceship these probes came from wouldn't need to be home to the aliens themselves. It's even possible that this spaceship couldn't talk to the probes before life started on Earth. It's like if there were intelligent beings out there sending out probes to learn about other planets, they might not know if anyone's home until much later. Loeb compared this to coming back to check your mailbox after a long time to see if there's anything in it, even if the people who sent the mail are long gone. Since Loeb first suggested that Oumuamua could be something aliens sent our way, not everyone agreed with him. Some people thought the idea was too out there and didn't have enough evidence. In 2021, a group of scientists wrote in a big science magazine that traveling between stars would take so long it seemed unlikely aliens would send Oumuamua to us. They thought Oumuamua was probably just a weirdly shaped rock that accidentally came into our solar system. Another group of scientists looked at Oumuamua's weird movements and said it wasn't because it was an alien spaceship. Instead, they thought it was releasing hydrogen gas, which isn't easy to see, and that's what made it move in unexpected ways. So, even though the idea of alien probes is fascinating and makes us think about all the possibilities out there, not everyone is convinced Oumuamua is proof of alien life. But the discussion helps scientists ask new questions and explore the mysteries of space even more. As Oumuamua leaves us with more questions than answers, a celestial journey might tell us more about the cosmos and where we fit in it. The boundless quest for cosmic companions. On March 22nd, 2023, even though there were a lot of questions and some doubts about strange objects in space, the Pentagon showed they were really interested in learning more about unidentified flying objects, or UFOs, that people have seen in the sky over the United States in the last year. Since a special group called the AARO was set up last summer to look into these UFO sightings, they've started over 360 new investigations based on what U.S. military people have reported seeing. About half of these mysterious sightings turned out to be balloons, or things that look like balloons. But for the other half, They just don't have enough information yet to figure out what those objects were. However, the people studying these sightings are hopeful. They think that by using telescopes to look closer at the sky, they might find more objects from outer space. This could help them test their ideas and learn more about what's out there. Thinking about how many planets there are beyond our solar system supports their hope. Just 20 years ago, finding the first planet outside our solar system was a huge deal. Now, we know about more than 4,500 of them. In about 10 years or so, we expect to learn a lot more about the kinds of things that move through our solar system. This will give us clues about what other solar systems and stars are like. The more we learn about space, the more we wonder if there might be life on other planets. The idea that there might be a huge alien spaceship somewhere in our solar system sending out tiny probes to check out other planets is really exciting. It makes the idea of exploring space even more interesting. A study done by a scientist from Harvard and someone from the Pentagon talks about how big and full of surprises the universe could be. They wonder if a super advanced alien civilization could be watching us with technology we can't even imagine yet. This idea makes a lot of people excited, but it also makes some people nervous. It's not surprising that some scientists are skeptical. They think the idea that Oumuamua, the space object that got everyone talking, might be an alien spaceship is a bit too far-fetched. But we can't completely rule out the possibility because there's still so much about the universe we don't understand. The debate about what Oumuamua is really shows how complicated it is to study things in space that are far away from us. While some people think everything about Oumuamua can be explained in normal, natural ways, others think we should keep an open mind because the universe is so big and there might be things out there we just don't know about yet. In the last few years, more and more people, including governments and scientific groups, have started paying attention to UFOs. They're taking sightings more seriously and want to study them carefully to understand what's really going on. The creation of groups like the AARO by the Pentagon shows that there's a real effort to look into these mysterious sightings properly. People have always been fascinated by the idea that there might be life in other parts of the universe. Whether it's using big radio telescopes to listen for signals from space or sending spacecraft to explore far-off planets, we're always trying to find out if we're alone in the universe or if there are other beings out there somewhere. With every leap forward in technology, we're able to look further into the depths of space than we ever have before, discovering new planets outside our solar system and catching the ripples of gravitational waves have opened up new chapters in the story of the universe. Each discovery is like finding a new piece of a puzzle, making us wonder about our role in the vast expanse of space. The idea of maybe not being alone, of there possibly being other beings out there looking up and wondering about the stars just like we do, brings up big questions about life itself. This curiosity pushes scientists to keep exploring, to go beyond what we already know and look for signs of life beyond Earth. We're not sure if we'll ever find clear evidence of life in other parts of the universe, but the journey of looking for it says a lot about our desire to understand more about the world beyond our own. The search for extraterrestrial life is a reminder of how much there is still to learn and discover. As we peel back the layers of the universe's mysteries, it's important to stay humble and open to whatever answers we might find. The universe is incredibly vast, filled with wonders beyond our wildest imaginations, and what we find out there might be completely unexpected. Meanwhile, our telescopes keep watching the sky, and our spacecraft keep flying into the great unknown, offering us a glimpse into the incredible vastness of the cosmos. Each discovery is a moment of awe, a reminder of the many mysteries that await us. The quest to find life beyond Earth is something that brings people together across the globe. It's a journey that goes beyond national boundaries, uniting us in a common purpose to discover and understand more about our place in the universe. Carl Sagan once said that the universe is incredibly large, and if we're the only ones in it, it would be a tremendous waste of space. This thought echoes the sentiment that the search for extraterrestrial life is not just about finding others, but also about understanding ourselves and our significance in the grand scheme of things. As we look up at the night sky, filled with stars and possibilities, we're reminded that we're part of something much bigger and more mysterious. Let's keep looking up, keep wondering, and keep exploring, because the universe is a grand book, and we've only just turned the first page. Could Oumuamua be a spy probe from an alien civilization, or simply a space rock on a cosmic exploration? Share your thoughts, and don't forget to like and subscribe for more mysteries.